Hello friends, welcome you all in my page Online Chemistry. Today we'll discuss about the ionic bonding and how ionic bonds forms. At first we have to look at our periodic table. This is our periodic table, and we can see all the elements here are 1s elements, S block elements, and these are P block elements, and these all are D block elements. All the A blocks elements, that is lanthanides, actinides, are here presents. That is lanthanides, actinides, these are all A block elements. Now if we see that these S block elements have S electrons and P electrons, and the configuration of these alkaline metals or these alkaline earth metals, electronic configuration, general electronic configuration are like that. NS1, NS2. Now after that, if we look at our P block elements, these P block elements, we see that the electronic configuration are like NS2 and NP 1 to 6. Now if this electronic configuration is NS2 and NP6, we know these are noble gases. All the gases in this zero group, here helium, neon, argon, krypton, xenon, radon, etc., etc. Now we know the basic requirement of forming chemical bond is to get an electronic configuration like these noble gases. Now if we see these groups, that is 5a, 6a, 7a, or in modern periodic table these are 15, 16, 17, like that. And if we look these groups 1, 2, 3, 4, etc., etc., there are only 1 or 2 electrons like that required to attain this noble gas configuration, electronic configuration. So these metals try to lose their outermost electrons, and these non-metals try to get that electrons. When these metals lose electrons, they form cation, and when these non-metals gain electrons, they form anion. And when these cation and anion will make, they are attracted by the Coulombic force of attraction. There is a charge, different charge attract each other, this relation, and they come closer and forms ionic bonds. The ions are forming bonding, so this is known as ionic bonds. Okay. Now we'll see here something. At first we check a group, a period, that is third period: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Here neon is present. So if we look at this group, what we'll see, we can see that if sodium lose 1 electron, it gains the electronic configuration of neon by losing 1 electron. If magnesium lose 2 electron, it will get the configuration of Na, like that. Aluminium have to lose 3 electron to gain the configuration of neon. Now we know after losing 1 electron, a sodium will be sodium cation. Similarly, after losing only 1 electron, magnesium get shall form Mg plus. And to remove the electron from the Mg plus is far more difficult than losing the first electron, as the when magnesium plus is formed, the attractive force towards the electrons by the nucleus is far more higher. But due to formation of the neonic electronic configuration, these two electron lose happens. Here, these two electron lose happens. For aluminium, this process is far more difficult. Aluminium to aluminium plus. After forming aluminium plus, it loses electron far more difficult way. And from aluminium 2 plus. After this, it will lose aluminium 3 plus. So this is far more difficult process. Okay. So what will we expect? We expect that this first one or two group, 3 group, these will lose electron to form the previous noble gas electronic configuration, and when we go to the right side, this process will be far more difficult, and they will form covalent bond far more easily. Okay. Similarly, for chlorine, it will get only one electron and it will get the noble gas configuration of argon. For sulfur, it have to take 2 electron to get the configuration of this argon. This is far more difficult, as sulfur when get 1 electron, it forms sulfur minus, and after that it have to get another electron, and when this electron comes, this extra electron will repel this electron, and this process is far more difficult. So to form phosphorus to P3 minus, it is far more difficult, like that. So to form anion in these groups is also far more difficult. So we see that 6 or 7 A, 6A or 7A or 16 or 17 groups will form ionic bond very easily, but before that these groups forms all the covalent bonds, like that. Okay. We know the basics of this ionic bond formation. Now when this ionic bond formation, it does not have any direction. The charge spreads in all directions. So the negative ions comes from all directions. Okay. And if the negative ion comes from all directions, so everywhere the negative ion can occupy. So these ionic bonds have no direction effect. Anywhere, any side in 3-dimensional area, the negative ion comes, and the number of negative ions can accommodate by a cation is termed as coordination number. The coordination number is the number of negative ion can be accommodated by an cation. Okay. And these are coordination number, and coordination number relates with the radius ratio of R plus and R minus. That's R plus means the radius of cation and R minus means the radius of anion. When R plus increases, so if the cation radius increase, it will get more anion, and if the anion radius increase, it will get less number of anion, because anion repulsion will be there. So the coordination ratio will be the radius ratio of the cation and anion. Okay. So this is our ionic bond. We will discuss further in our next video.